Okay, so today I will present the pair diffusion, a comprehensive multimodal object level image editing. So it published CVPR this year. So it is the framework that enabled diffusion model to control the structure and the appearance of every single object, in the image. So the application that they test is the appearance editing, like this one, like changing the color of the hair, random appearance editing, and also a reference. Freeform shape editing. The shape of the hair here and here is different. Adding object to the original image, and I think this one. There's a weird meat and beer here, and image variation. So for the related work, there are some existing work on image editing, for example, using text prompt as instruct pics to pics. It's have limited capability on fine grain control on the object level, and it's difficulty because of like describing the shape and the appearance. Using text is very difficult, and like it's rely on like how we prompt. So prompt engineering is also another like tedious and time consuming job. And another line of work is like using a lower level conditioning signal. It could be mask or sketch or like image or the image editing. But it's also hard for the prompt engineering, and also it failed to like independently manipulate multiple objects in the same image. And there's another line of works recently using like spatial textual or image control. So it's explicitly telling the model the spatial conditioning to control the structure, and also the text prompting to define the appearance of the region of interest. So like most of the related work, it like the object level editing capability, and also it's relied mainly on the text, but like using text to describe like how the appearance should be also very hard. So the contribution of this paper, it's formulate the image editing task. So it can do like more comprehensive edit capability, and also it used the multimodal classifier free guidance, which leverage both the reference image and also the text to control the edit. And also the control signal of like each component, whether the reference image or the text image or the text prompt, also can be controlled by the user, and it's allow independent edit the structure and the appearance of object like simultaneously. So this is the overview of this pair diffusion. So for the training, so first they will extract the structure and the appearance segmentation information, and then it put into the diffusion model in a conditional manner. And later then in the inference part, yes, It also extract the structure and the appearance of the given image, and also it extract the appearance information from the reference image, and then uh, adjust some strength of the conditional signal, and it will give us the final output. So for the structure and appearance extraction, so for the structure, they use the panoptic segmentation map, and like using this one, it return the shape and the category of every single object. And for the appearance, so it capture two level of features. One is the lower level for the color, for the texture, and it use the convolution encoder VGG. And for the higher level feature, for the complex object, let's say like face or like cars, it use the transformer base encoder Nino V2. And to extract like per object appearance representation. So first it like extract the feature map, and then it pass to pass the shape of the object to pull over the spatial dimension, and then we obtain the appearance presentation. So this one is the GVL is the lower level feature from VGG, and this two the is from the higher level from the Dino V2. And then for the training, so it use the representation that we have just extract before the train. So there are two versions. Like the first one is the unconditional diffusion model. They use the latent diffusion model for the baseline, and use the stable diffusion for the foundation text to image. And to condition the stable diffusion, they use the control net, and it controls the inner layer of a stable diffusion will focus on like the higher level feature, and then the outer layer will focus on the lower level. So the object function here is just like MSE. And here the text prompt, it will be null for the unconditional diffusion model. And for the image editing formula, they formulate the image editing task into a general formula. It's quite intuitively. For the appearance editing, it just like swap. So this is the appearance representation, and it just like swap to the edited one. For the shape is also the same, while keeping like the another one the same. Adding object, it just like we specify the new object structure and appearance representation, and then we include it into the like original one. And this one can be from the reference image, or like from the SketchUp user, or like from text prompt. And for the object level image variation, it could be from the like nature diffusion, or it can be like the information loss in the pooling process. And the inference, so in the inference, we can adjust the strength of the like different conditional signal. So the conditional signal here is like SS, SF, SY. S is the shape, the structure. F here is the appearance, and the Y here is the text prompt. So as we increase or like decrease it, it will make the final output like more smoothly be edited. For example, like for the appearance the appearance representation of the reference image will be more informative than a text prompt. So they usually like set the SF larger than SY. And the text prompts be like disjoint independent from the reference image. So for the experiment, they training the unconditional diffusion on the LSUN dataset and the Celeb A HQ dataset, and they do the quantitative experiment here. And for the fine tuning, the diffusion model, stable diffusion, they use like the COCO data set and they do the qualitative experiment. And the training is, it takes like several days. I think like for the diffusion, it takes like 3 days. So first we will see the qualitative comparison. To compare the appearance editing, they compare with the PFD model. So we have the reference image here. This is the input image. Here's the reference image. So this one is the one that don't have the text prompt. And we can see that like for the pair diffusions, it shows like much more better than the baseline. And with the one that have the text prompt here, for the like PFD, they cannot include the text prompt, but for pair diffusion, they did include like some birds on the sky. And the same with the another case. For the adding objects and the shape editing, the baseline is PPE, and so for the PPE, it can include the cake on the table, but the thing is like it cannot do the shape editing, like change the cake from the circle to the rectangle. And yeah. For the object variation, so this is so they don't have the baseline for this comparison, but it shows that like for with a different seed, it can generate like more the variation of the input image. So for the quantitative result, the objective is like to verify whether it can control over the editing properties, both the structure and also the appearance, and they don't aim to be like the best one. And the evaluation criteria is like the naturalness, the locality, and the faithfulness. So they have the like evaluation metrics here. The FID is for whether the edit image look realistic. L1 distance for is it the edited region is like in the specific one, And the SSIM is like, should be like resemble the target image. So we can see here, this is the visual result on the LSUN data set, benchmark like bedrooms, and it's performed well in compared to other baseline here. And it also show like effective appearance control, changing the color of the bed line. And when we see the quantitative result on the appearance control, so the smallest is, yeah, the smallest is the better for these two. They are not the best state-of-the-art model, but they showed their result is also like perform well. And the evaluation on the Celeb A validation set, it compare with a scene model, and they compare they use the conditional model on the ground truth, and then segmentation, the result, the generated image with the pre-trained model, and then report the MIOU score and the SSIM. Here's the result, and it's actually outperforms scene, not that much, but still, and it show the precise structure guidance and the appearance like editing. And for ablation study, so they try to change the SY, like the strength of the conditional signal of the text prompts, and like the more we set for the for this signal, the better result we get. But the thing is, for the standard one that they don't consider the text, there's nothing changed. Like it's a promise like snow on it, and there is no snow here, and like if we ask for the bird on the sky, and like there's no bird, so that's why I like use the multimodal that also like including the text points. And so the conclusion is, so they use they enable the object level structure and appearance editing for each object, and do it simultaneously with the diffusion model. And also it have using the multimodal classifier free guidance. So it will provide like precise control on like editing operation. And for the limitation, so the conditioning of the structure and the appearance, they use only a simple formula. So that's why for the future work, they wanna come up with a vector or like a way to do the extraction more like sophisticated, and also standardize the magic for the image editing task. Thank you. Do you have any question?